Hi, today we are going to be proving independence. We will prove mathematically that two events are independent. And today we're doing this without a table. So we're going to say non-table because it could be Venn diagrams, but it could also just be, numbers that I give you. I tell you probabilities. Okay, so independent events, the first event does not affect the second event. So for example, I'm taking a test today, the probability that I pass the test, given that it's raining, or the two events, whether I pass a test or it's raining, those two things do not affect each other. So that's the kind of the idea. So there's two ways that we can do this. One is the conditional probability, where the probability of A given B is equal to the probability of A. So basically it just means that it doesn't really matter if B exists, A is going to happen, and that probability is it. And the other way, well, you don't cross out that, sorry. You still need it. But those two are going to be equal. Or the probability, you could also show the probability of A and B is equal to the probability of A times, so multiplied by B. Those are the two ways we are going to use to prove, or, we're going to use when we're dealing with independence without a table. Why? Okay, so determine if the events are independent. So we pick one or the other of those ways to prove depending on what they give you. So in this case, we're given an and. So it really just makes sense that we would use the one that has an and. Okay, this one down here has a given, so we'd use the one that has a given. And that's really it. That's the criteria. Okay, so what you do need to do is write the rule that you're using. So I'm using if the probability of A and B is equal to the probability of A times the probability of B, then it's true. And whenever we're doing a proof, we don't cross the equal sign. So probability of A and B is 3 out of 20. Probability of A is 3 out of 5. The probability of B is 1 out of 4. We do the math on one side. We're going to leave this by itself. If you feel better, you can write it as a decimal. Doesn't really matter if you like that. But multiplying fractions is no problem. You multiply the top. You multiply the bottoms. So 3 over 20 is equal to 3 over 20. So these two events, A and B, are independent. I totally spelled that wrong. Whatever. That's good enough. You get the idea. So for this one, same thing. I'm going to be using the same rule, so I write it. So remember, and is the same as this. I didn't make it that well. So the probability of A and B is equal to the probability of A times the probability of B. So I'll rewrite that. A and B is 3 out of 50. Probability of A is 3 out of 10. Probability of B is 1 out of 4. Just do the math on either side. 3 out of 50 is not equal to 3 out of 40. So these are not independent, or they're dependent. So this one has a given, number 3 has a given, so I'm going to use the probability of A given B is equal to the probability of A. So remember, it's always the first one that's sitting here. So the probability of A given B is 1 out of 5. Probability of A is 1 out of 2. These are not equal, so these are dependent or not independent. Yeah, that one's a lot easier. I wish we could do that one all the time. So just have to write the rule. Probability of A given B needs to be equal to the probability of A. So A given B is 9 out of 20. A is 9 out of 20. This is correct. So we say, so they are independent. That's it. Okay, so another possibility is if I tell you they are independent. So if I tell you that two events are independent, then you know those rules apply. So that means I'm allowed to use those rules to figure other things out. So A and B are independent. So the probability of A and B, you don't really have to write the rule when you're doing it this way. So the probability of A and B is equal to 11 over 80. That should be equal to the probability of A times the probability of B. Now you can write probability of B, but I'm just going to write an X because that's just easier to me. So you can either divide by 1/4 or multiply by 4/1, whatever you're most comfortable with. So if I multiply by 4/1, these guys cancel out, and I'm left with 44/80, or 11 out of 20, depending on how they want the answer. But unless they tell you to reduce, you don't have to do extra math. So this one is the same idea. So 39 out of, we're telling you they're independent, so 39 out of 100 is equal to 13/20 times X. We're making that our X. So I'm just going to multiply by the reciprocal, or you can just divide by 13/20 when you have your, your calculators. They just do that. Okay. These cancel themselves out, so you're just left with X equals, and your calculator will reduce it, so you can do 0.6, but generally if you, if the question is in a fraction, the answer should be in a fraction. All right, probability of B given A is 3/10. So since these are independent, B's should be the same. That's it. I know, it's that easy. Probability of A is here. If these are independent, then the probability of A is equal to 11/20. Probability of B is just extra info. Okay? All right, so now we have, a little bit more complex problems. So might have to use Venn diagrams, yada, 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 yada. All right, so draw a Venn diagram to model this event. You may want to take a second and read it. I could probably pause it at some point. So it's 2 events. The probability, it's probability, so the whole universe of this thing is 1. So we do loud music and hearing loss. I guess I could use 2 different colors. That was poor. Okay, so the probability that they listen to loud music is 0.15. So loud music goes there. Probability that they have hearing loss is 0.4. The probability they do not listen to loud music or have hearing loss, so they don't do either, so that's out here, is 0.51. Okay, so to do this one, again, whenever we're doing Venn diagrams, we always have to do the middle part first. So the basic, there's many different ways to do this, but if you add all of these together, all these numbers together, you should get 1. So if I get 0.15, 0.4, 0.51, I did this a different way on my paper. Whatever. I get 1.06. I subtract 1, so I get this is 0.06. An alternative to doing it this way is to stick with the way that we kind of have been doing it. And if the probability this is not, 0.51 is the probability it didn't happen. What the probability that either one happened would be 0.49. So we would just add 0.15 and 0.4 and subtract 0.49 from it. Either way, we're going to get the same answer. This guy here is 0.09. This is 0.34. Are these 2 events independent? So when we're doing this one, you could do the given probability, but that one's a little bit harder. So I would have to say do the AND one, tends to be the easiest in my opinion. So the AND is equal to each of the individual ones. So we just have to find those probabilities and put those in here. So the AND is 0.06. Probability of loud music, that's the full loud music situation. So loud music is 0.15. And the full hearing loss, so that's 0.4. You multiply those 2 together, you get 0.06. So these two events are independent. That's it. That's the idea. All right, another example, the probability that Nathan plays baseball today is 0.45. The probability that he plays baseball given that it rains. So remember the word given is the conditional probability. The probability that he plays baseball given that it rains, excuse me, has to be equal to the probability that he plays baseball. That is the rule with the given conditional. So it's raining is 9 out of 20. Baseball is 0.45. You're not sure if these are the same or not. Figure out the decimal equivalent of that. It is 0.45. So these two guys are independent. Nathan really likes baseball. Okay, and then finally, a little bit more. Wake up. Wake up. Stop falling asleep. This one here, oh, tricky. That's an or. That's not an and. So here's an and. And is the upside, is the A. And looks like that. So that's an or. So we can't use that. Neither one of those are in there. But if you remember the formula for and, it's the probability of A and B is equal to the probability of A plus the probability of B minus the probability of A or B. I apologize for going into the other problem. I always feel bad for the other problem. So we don't have this one, but we have A, we have B, and we have A or B. So we have to use this because we don't know if they're independent or not. So we can't just like multiply and figure it out because they are not independent. So this is the rule when they are not independent. So when you do the math, magic happens. This is 2 out of 5. I'm just running out of space, so 2 out of 25, excuse me. Okay, so now that I know what the probability of A and B is, it's 2 out of 25, I just use the rule, probability of A and B is equal to the probability of A, or not the rule, the method to prove. So probability of A and B is 2 out of 25. Probability of A is 2 out of 5. B is 1 out of 5. So excuse me. Oh, they don't give me the white. So 2 out of 25 is equal to 2 out of 25. Check. These guys are independent. Okay. Other possibilities of us giving you not and be able to use them. So it's not just